Okay, today we are going to learn how to do a coordinate geometry proof with a triangle. So the first thing that we need to know is what types of triangles we could have. So to classify the following triangles, this is a right triangle. It's got one right angle. This second one here is called an isosceles triangle, and it's got two congruent sides. The third triangle is called equilateral, which means it's got three congruent sides. And the fourth one is called a scalene triangle because it's got no congruent sides. So today we're going to learn how to do these in coordinate geometry proofs. So you might want to take out a piece of paper or some graph paper so that you can follow along and copy these down. So if we look at the first example, we want to prove that we have an isosceles right triangle. So here, isosceles means two congruent sides. That we do with the distance formula. Right means that there's perpendicular sides. So that means we're going to do slope formula. So once again, I'm going to hit pause, I'm going to do the work, and then I will come back to you and explain what the work shows. Okay, if we look at the work, the plan here, and this is a little tricky, I am going to do three distance formulas to show only two congruent sides. Because in order for it to be isosceles, only two sides have to be the same. And you have to show that the third is different. And I'm going to do two slope formulas to show a right angle. So if I look at my distance, I find out that PQ here has the same distance as QR. So in my so they're congruent. RP is different, so it's not congruent. So when I started to write my conclusion, I wrote, since the length of PQ and QR are the same, they are congruent. The length of RP is different, so it's not congruent. Since only two sides of the triangle are congruent, it's an isosceles triangle. Now we have to focus on the slope. When you're trying to find a right angle, you want to cheat a little bit and look at the picture. I looked at the picture and it was clear to me that if I look at side PQ and side QR, it looks like that's where the right angle is. So I picked those two sides to do the slope formula. They are negative reciprocals. So then here in the conclusion, I wrote, since the slopes of PQ and QR are negative reciprocals, Q is a right angle, so triangle PQR is an isosceles right triangle. Okay, the next one says prove triangle XYZ is an isosceles triangle. So the first thing, isosceles means two congruent sides. So that means we're going to do three distance to show only two sides are congruent. So once again, I'm going to hit pause for a moment. I'll do the work and I'll come back and show you. Okay, if we look at the work, once again, I did graph the picture. I wrote down my plan, which is I will do three distances to show only two congruent sides. I wrote down my distance formula here. I did my distance for all three sides. I got radical 13, and 4. And then in my conclusion here in the black writing, I wrote, since the lengths of XY and YZ are the same, they are congruent. ZX has a different length, so it's not congruent. A triangle with only two congruent sides is isosceles, so triangle XYZ is isosceles. Next question. It says prove triangle DEF is a scalene triangle. So the first thing, vocabulary, scalene, that means no congruent sides. So to show congruent sides, we're going to do distance. So here I have to do three distance formulas. So once again, I'm going to hit pause and then I will come back and explain my work. Okay, if we look at the work, again, my plan is I'm going to do three distances to show no congruent sides. I did the distance formula for side DE, EF, and FD. Notice all three answers are different. So in my conclusion, I'm going to write, since the lengths of all three sides are different, none of them are congruent. A scalene triangle has three different length sides, So triangle DEF is scalene. Okay, last question. It says prove triangle CAT is an equilateral triangle. Equilateral, so 3 equal sides. So 3 congruent sides, and we do that by doing distance. Once again, I'm going to hit pause, I will do the work, and then I will come back and explain it to you. Okay, so I must have screwed up when I wrote this question, because when I did my work, technically, if this was on the Regents exam, if they said to prove that it is equilateral, as it says here, these 3 answers, here, here, and here, have to be the same. I must have copied one of the points wrong, because I double-checked my math. These 2 sides are the same. This is different. So this, we're going to say, is a bad question. Again, if it's on the Regents, it would have worked out for you, and you would have gotten 3 of the same answers. You would have said, since all 3 sides are the same length, it is an equilateral triangle. Again, make sure that you write down any questions that you have and email me or ask me next time you see me.